Hi students, welcome back to another e-lecture, this time on living with tectonic hazards. We are now looking at Gateway 2, what landform and associated tectonic phenomena can be found at plate boundaries. Now in this video, we will be learning about tectonic happenings, the landforms it creates, and the phenomena that contributes to them. The landforms are easily seen and they are recognizable, naturally formed features on the Earth's surface. On the other hand, phenomena aren't quite so visible, although if you've seen rocks under your feet wave and tremble, you'll probably disagree. But essentially, phenomena are facts, occurrences, and circumstances that are observed, which doesn't mean that it's seen, but more that it's measured and keenly studied. We'll begin with learning about landforms, and there are three of them that we'll be studying. The first landform that we are learning about are fold mountains. They are mountains created by the folding of rocks, usually sedimentary, which are forced upwards towards the heavens. The Himalayas are a range of fold mountains you may be more familiar with. This is one of the younger fold mountains in the world at less than 100 million years old, and it is still growing. You might still remember last year's tragic earthquake in Nepal, which killed over 8,000 people and destroyed much of Kathmandu, its capital. Now that is evidence of the Himalayan range still experiencing great change, as young fold mountains like these are located along active plate boundaries and they are still growing taller. In fact, Mount Everest actually moved 3 cm to the southwest after the 2015 quakes, proof that our Earth is a lot more dynamic than you think. Now, as you remember, fold mountains are located along convergent plate boundaries, and a compressional force at this place causes the layer of rocks to buckle and fold. This process is known as folding. Now, you see these cute little corgis on the right hand side, it means that this is something you need to pay attention to and you may want to copy down. Okay? Now this is the folding process. You may want to pause to read it or search YouTube for videos on how this happens if you can't visualize it. More such videos may also appear on the job website over time. It's just too boring for me to read this and for you to hear me drone on and on. So pause if you need to. And draw this diagram. This diagram is something you need to know. In fact, any diagram that looks like this, black and white, is things you need to learn to draw. So do draw them out. Now, while plates being squeezed together causes mountains to be formed, the pulling apart of tectonic plates also causes landforms such as rift valleys and block mountains to be formed. And this is the second landform that we are learning about. Now, these are the distribution of rift valleys and block mountains in the world. There are some in New Zealand, which I'm going to look for things for me to look out for, okay? I still have not planned my trip. Now, the East African Rift Valley is the one that we'll mainly be learning, and this is formed when the Nubian section of the African plate and the Somalian section of the African plate are pulling apart from one another. So this breaks open the land and causes what you see in this picture below. You may also have seen pictures of this when we learned about divergence. Now this happens because of the faults that are created. Now in geology, a fault is a place where sections of the crust of the earth move relative to one another. It is where there is a fracture, a breakage, and the rocks are displaced. This is because of the tensional forces that are created by plate movements. Now this process of rock fracturing is called faulting. Just like how faulting people over every little thing can cause their spirit to break, faulting causes the rocks to break. A rift valley is a valley that has steep sides formed along fault lines. Now, valleys are formed when the tensional forces cause the plates to split apart and a center block drops between the two blocks. So these two are pulled apart and this falls through. Okay, if you want to learn how to draw very clear and simple diagrams to illustrate these, go to the link that I will post below. Now, on the other hand, when you have more of such fault lines, you create block mountains, which is essentially a block of land with steep sides that is formed when sections of the crust that extend along fault lines and rock masses surrounding a certain central block sink due to tensional forces. So these two are left behind. Okay, the block of land left standing higher than the surrounding land becomes a block mountain. Essentially, you become a mountain because others fail to be mounted and other pieces of land fall. Okay, so these are the landforms that you will find in the East African Rift Valley, and this is because of how rocks float on one another and drop and rise because of the different plate movements. Now, the third landform that we are learning about are volcanoes. This hold the greatest mystique and interest in geography, and is a highly studied yet still highly unpredictable science. Now, a volcano is a landform formed by magma that is ejected from the mantle onto the Earth's surface. And this is where they are located around the Earth. You realize that there are many of them, once again, around the Pacific Ring of Fire. Now, when we think of volcanoes, this is most likely what came to mind. And indeed, while the parts of the volcano are largely alike, there are still nuances that cause them to look slightly different and to grow and appear differently. Now, the parts of the volcano that largely stay constant are the magma chamber and the vents. And volcanoes are built from Earth's inner material, its main ingredients, melted rocks that form the mantle. However, they are named differently. Okay, when they are still inside the volcano, they are called magma. They are still molten and gooey and sticky. Once on land, they are called lava, like in chocolate lava cake, and will eventually solidify and harden due to Earth's surface lower temperature. And this lava is precisely what determines the volcano's shape and size. Now, the main characteristic of the lava that we study is viscosity, which refers to the stickiness of the lava. Think of cookie dough while we continue. I'll tell you why later. The most common types of volcanoes we can find on Earth are shield volcanoes and stratovolcanoes. Now, shield volcanoes are volcanoes that have gently sloping sides and a broad summit. Okay, examples include the Mauna Loa, which is in Hawaii in the United States of America. So you may not think that they'll grow very tall, but this guy here is 4,169 meters tall. If you remember my story about driving up it, we actually drove for half an hour and couldn't figure out where we were and why it was so cold. And we checked the GPS and we were at 2,000 meters up. Yep, that was scary. So shield volcanoes actually get really tall despite the fact that they don't look very tall. And this is because of the lava that they have. It ejects lava with very little silicon content, or what we call low silica lava, the same silica that goes into glass. Now, low silica lava has low viscosity, which means that it flows easily, and this allows the lava to spread across large areas before solidifying. These cause gentle, non-explosive eruptions that resemble slow-moving chocolate, flows more than explosions. Now, the base of shield volcanoes expands as the lava accumulates over successive eruptions, causing it to grow taller but not very obviously. It largely looks fat. These are common near divergent plate boundaries where magma rises directly from the mantle. Shield volcanoes can also be found at hotspots in the plates, as is the case in Hawaii, and this is some Pahoehoe lava from Kilauea volcano in Hawaii, USA. And it looks like ropes because of the way that it flows gently and then solidifies slowly as well. You can see actually it's still very hot here. Now, on the other hand, we have stratovolcanoes, which have much steeper sides and look more like the mountains we expect. These develop from successive eruptions of lava and ash. An example you can see is the Mount Mayon of Philippines. Unlike shield volcanoes, stratovolcanoes are formed from high silica lava, which is more viscous and traps gases. This magma is formed from the high pressure melting of oceanic plate underground during plate convergence, which also traps water and associated gases. The magma is angry and boiling and expands and explodes upon eruption, raining lava, ash, rock fragments, and gases on the earth. Now, these include the light rocks like pumice, which you can find in my rock kit, up to 1-ton car-sized pieces of rock. Now, the initial eruptions of a stratovolcano begins with ashes and coarse rock fragments, and the subsequent eruptions of lava covers this ash, which prevents its erosion. So layers of ash and lava will continue erupting, building a high volcano, which is steeper at the top and gentler at the base. So the secondary cones may also develop as the magma seeps into the sides and erupts because of the very explosive nature of this kind of volcanoes. Now, stratovolcanoes are more hazardous because of this thing called pyroclastic flows and lahars. Pyroclastic flows are hot rock fragments and superheated gases which thunder down slopes, while lahars are pyroclasts and melted ice. Together, they are like landslides from hell. They move very quickly and they cause great loss of life and property during the Krakatoa eruption. The next part of this gateway that we're going to cover is phenomena, but because it's still quite long and we're at the 10-minute mark, it's going to go into the next e-lecture so that you are not overloaded with too much information. So do read up on earthquakes and volcanic eruptions before we move on. I'll see you again in the next video. Hope you have a good time studying and that you managed to learn something today. Bye!